Where's the oh? So today we're doing the orange slice significance test.
Hi, my name is Desiree Lazaro.
Hi, my name is Duyan Lee.
My name is Nile.
And my name is Laura Agboon.
So for our introduction, we did the question of interest was Cutie Orange Company claims that there is a mean amount of 10 slices in their oranges. Is there convincing statistical evidence that the mean number of orange slices is different from the company's claim? Why did we choose this topic? Well, first of all, we really love eating oranges. Second, it's super refreshing and healthy. And third, we wondered if the mean slices in our sample data would actually differ from the population mean slices of cuties.
So, how do we plan to analyze it? We would first up we would list the locations from 1 to 4. Number 1 would be target on Silver Creek Road. Number 2 would be target on Story Road. Number 3 would be target on Capitol Avenues. Number 4 would be target on Monterey Road. We first use a random number generalizer to select 2 locations. Select locations number 1 and number 2. Then we would identify those locations to buy the cuties oranges from. Would be target on Silver Creek Road and target on the Story Road. Then the second step would be at the selected store the number of cuties bags from number the orange bags from 1 to n. Use a random number generalizer to randomly select 2 bags of orange cuties. Then we would take 17 oranges from each bag, then peel them. We would count the number of slices from each orange and mark it on the table. Then find the means of 34 oranges combined. Perform a 4C method to see if there is convincing statistical evidence of there being a difference in mean number of slices found in orange cuties.
We collected our data by first using bag 1 that we bought from Target in Silver Creek Road, and then buying the second bag that was generated from the random number generator, which was the Target in Story Road. We then labeled the amount of oranges in bag 1 and bag 2 from 1 to 34. And when, for example, when we peeled orange number 1, we found that there were 9 slices. And then when we peeled orange number 2, we found there were 10 slices, and so on.
After we got our data collected, we continue to use the 4C method. We choose one sample t-test for population mean. Our parameter is the true mean number of slices for all cutic oranges. The hypothesis or HO, the population mean equal to 10 slices, and the HA is population mean differ from 10 slices. The significance level is 0.05, and our statistic is 9.5882, which is the evidence for HA because it's different from 10 slices. Next, we check for conditions. We got the random sample of 34 cutie oranges from using cluster sampling, so we can generalize the population. 34 is less than 10% of all cutie oranges, so we can sampling. So sampling without replacement is okay, and 34 is greater than 30. So the sampling distribution of sample mean is approximately normal. So all the conditions are met. Next, we calculate. We use a general formula. Test statistic equals statistic minus parameter over standard error, which is 9.5882 minus 10 over 0.9883 divided by the square root of 10. And we got a t statistic equal to negative 2.4296, and the p-value is 0.0207. Then we can conclude that assuming HO is true, there is a 0.0207 probability of getting a sample mean of 9.5882 or higher, and a negative 9.5882 or lower purely by chance. because the p-value is 0.0207 is less than 0.05. We reject HO, and we do have convincing evidence that the mean number of slices in cutie oranges differ from 10 slices.
Okay, so for our findings, we did a mosaic plot to present our data of the orange slice significance test. As you can see, the minimum amount of orange slices is 8, maximum amount of orange slices is 12, our median was 9, and the mean was 9.5882, with quadrant 1 being 9 and quadrant 3 being 10. For our data summary of research, we stated that the distribution of orange slices is roughly symmetric with the mean at 9.5882 slices. The IQR is 1 with 50% of the data being between 9 to 10 slices. The sample distribution has the same median, and Q1, which supporting that graphing is roughly symmetric. There is no possible outliers in the graph.
So the potential problems is that as orange season range from November to June, this is an indication that oranges can be typically larger. Thus, there is a possibility that the size of oranges in our data is a confounding variable. So how could we improve it? To further reduce the variabilities of our sampling distributions of the cuties orange slices, we can improve our observed studies by increasing the sampling size. In this case, we would buy more bags of orange from different kind of stores.
So this is our final summary of the project. After doing this study, we can confidently say that there is convincing statistical evidence of there being a difference in mean number of slices found in orange cuties. We can say this because since the p-value 0.0207 is less than 0.05, we can reject our null hypothesis, and we can say that we do have convincing evidence that the mean number of slices in a cutie orange is different from 10 slices. However, we did have limitations when doing this project. We only sampled 2 bags of oranges, which was only 34 cutie oranges in total. To add on, we only considered only a few target locations in our proximity, and instead we could have used more target locations and more cutie orange bags in order to reduce variability. And in order to better answer our question of interest, we can say that we can repeat the number of studies we do during different seasons in order to understand the possible changes and differences in fruit quantity over time. And lastly, we can improve our study by increasing the number of orange bags to get a more reliable data set. And we can also consider a variety of target locations instead of only limiting it to only 4 locations and using 2 locations from those 4 locations. And then we can also repeat the study multiple times to ensure that our data is both reliable and consistent. And these are pictures that we took when doing this study. Thank you.
Thank
Thank
you.
you. So, in conclusion to our study, we found statistical convincing evidence that the mean number of orange slices is different from the company claim. Since we reject HO, the popular mean equal to 10 slices, we can conclude that the type 1 error could have been made. In this context, we found convincing evidence that the mean number of orange slices is different from the company claim, but we actually have the mean of 10 slices in reality.